In this video, we will learn about the turning effect of a force. So, first of all, to understand the turning effect of a force, let us consider the following examples. So, if you apply force on the handles of a door of your classroom, the door turns around the hinges. Means these are the hinges, the door is fixed here, and when we apply force on the handle here, so the door will turn around the hinges. Then, when you apply force with your foot on the pedal of the bicycle, the pedal turns about the pedal axis, like here we can see. Then, when a force is applied tangentially on the rim of the steering wheel of car, so here we are applying force tangentially, means along the tangent of the steering wheel of a car, it produces turning effect in the wheel. So from all these examples, we can clearly see that if an object is pivoted at a point, means if an object is fixed at a point, then a force applied on the object produces a turning effect, means the object will start rotating. It will undergo rotational motion and it will produce the turning effect about the axis passing through the pivoted point, means the axis will be passing through that pivoted point and the object will show the rotational motion. Now let us talk about moment of a force, which we call as torque. So we can say that the turning effect of a force on an object about a given point or a given axis is called moment of the force, and moment of the force is also called torque. So here let's consider a rigid object that is placed on a table and pivoted at point O. So this is the point O and here the object is pivoted, means it is fixed on the table. Let a force F be applied on the object at a point P. So we are applying the force on this object at this point, that is point P. So force is applied in this direction. Here we can see. Now when we are applying the force, since the object is pivoted at a point, this is a fixed point, so the object cannot have a translational motion, but it can rotate about a vertical axis passing through the point O. So here we can see this is the axis of rotation which is passing through the fixed point O. So the object can rotate about this fixed axis. So we can say that the turning moment or torque of the applied force is given by the product of the applied force and perpendicular distance between the line of application of force and turning point. So here we can see that this is the turning point and this is the line of action of force and the perpendicular distance is d. So from here we can derive the formula that moment of the force or torque is force into perpendicular distance between the line of action of force and turning point, that is F into OA. So OA is the distance which is d. Now this torque is generally represented by the symbol tau. So this is a Greek letter which is pronounced as tau, and if the perpendicular distance is d, then tau, that is torque, is F into d. And from this relation we can tell that turning effect of the force depend on the product of magnitude of the applied force, what is the magnitude of the force, and the perpendicular distance d between the line of action of force and the axis of rotation. Now let us talk about the units. Units of torque. So here we can say that the unit of torque is the product of units of force and distance only. So in SI unit we know that the unit of force is Newton and the unit of distance, the SI unit of distance is meter. So the SI unit of torque will become Newton meter. Now if we talk about CGS, so CGS unit of torque will be dyne centimeter, because for force the CGS unit is dyne and for distance it is centimeter, and 1 dyne centimeter will be 10 to the power minus 5 Newton, because 1 Newton is 10 to the power 5 dynes, and 1 meter is 100 centimeter, means 10 to the power 2 centimeter. So 1 centimeter will be 10 to the power minus 2 meter. So from here we can say 1 dyne centimeter is equal to 10 to the power minus 7 Newton meter, or 1 Newton meter will be 10 to the power 7 dyne centimeter. Sometimes the units kgf, m, kgf is another unit of force. Okay, then we have gram force and centimeter, they are also used for the moment of torque. So 1 kilogram force meter will be 9.8 Newton meter, and 1 gram force centimeter is 989 centimeter. So I hope it is clear to you. Thank you.